So today we're going to learn about standard position and coterminal angles. There's lots and lots of vocabulary that you need to pay attention to as we go through this lesson. So I would encourage you, either as the video is playing, to pause and stop it, write vocabulary down, definitions, or if you want to go through the reading, all this vocabulary is listed there as well and defined. Another thing that's going to really help you with this lesson and all the vocabulary we're going to encounter is that you definitely want to use pictures when we start to talk about angles and talk about coterminal, standard position, initial side, terminal side. All this vocabulary it becomes way more clear if you draw a picture of it. For instance, if you are given a problem and they say, what angle is coterminal to a 170-degree angle, okay? Then what you want to do is you want to draw a proper 170-degree angle. Now, it can be an estimate like I'm doing right here, but that's a proper way to draw it. And so we're going to talk about this as we go through the lesson. So pay very close attention to vocab and pictures, how they go together, and then watch how I'm doing the problems. I let the pictures tell me how to think instead of trying to do this in my head. Doing this in my head is a great way to make lots and lots of simple mistakes. So be very careful. I don't do that. This is how I get good at math, or how I got good at math. I wrote things down. I drew pictures. I made sure I understood what I was talking about. Same thing I want to happen for you this semester. So the first thing we want to do is we want to draw an angle. Now, in geometry, an angle is the union of two rays, okay? It's the union of two distinct rays with a common endpoint. Okay? So when I say two distinct rays, that means I need two rays that go in completely different directions and they have a common endpoint. So this would be considered an angle, just the rays and the common endpoint. Now, we modify that definition a little bit when we get to trigonometry. We start to think of angles as sort of rotating. So what we do is we take this first ray, okay, which we call the initial side of the angle, the initial side, and then we take that ray and we rotate it, okay? And as we rotate that ray, wherever we pause, whenever we pause, that ray then becomes the terminal side. Now, this is essentially the same definition as geometry, although we're adding a little motion to it. Why do we add motion to it? We add motion to it because that's what the Babylonians did. That's what the Mayans did when they started to think about the days of the year and the earth rotating around the sun, and they decided 360 was a really important number, okay? And because it was close to 365 days in the year, all right? And so they ended up dividing a full rotation into 360 parts, Okay. It's very interesting that the Babylonians had what's called a near base 60 number system. And while the Mayans had a near base 20 number system, and both of those were because 60 and 20 went evenly into 360. And so if you study the ancient number systems, you start to see this relationship with the idea of 360 as being really important. In any case, that's why we get that rotation and why we start to talk about the measurement being a degree. Okay? Remember, the measurement could be done in two different ways, degrees or radians. But the degree comes from this sort of rotation idea. Radians comes from another place. Now, the common endpoint is called the vertex. So you want to keep that in mind. So a very interesting thing happens when you make this sort of definition. If you have an initial side and then you rotate in some direction and come up with a terminal side, nobody said what direction you have to rotate. You'll notice up to now, I have mostly rotated counterclockwise. Okay? Counterclockwise, or going backwards of the direction that a clock goes, is really considered the positive direction for angles. Now, I will show you later why we consider it the positive direction. But you could just as easily had an initial side here and rotate it in the other direction to get a terminal side. And if you do that, that would be clockwise rotation, and clockwise rotation is associated with negative direction. Okay? Clockwise is associated with a negative direction. So you need to make sure you keep track of this, because as we move on in the chapters, it's just automatically understood when you see positive or negative, you know which way the rotation is going. And the way we rotate is really important, where that terminal side ends up. It becomes, a big deal. And if you mess that up, then you get problems wrong. So pay attention to that. That's really important. So what happens is we need to define a standard position, because otherwise what happens is you have these terminal sides, initial sides and terminal sides, and you could put them anywhere and you're just rotating willy-nilly to get all kinds of angles, and nobody knows where you're going. Plus, whenever you draw an angle, oh my gosh, look at this. You could have gone two different directions and got exactly the same terminal side. So we've got to, what mathematicians do is they standardize things. We've got to have a place where we start and we understand that's the base place to start. And so interestingly enough, we do this on a graph. So if I were to draw a coordinate system, okay, our old friends, the XY graph, just an XY coordinate system. And what I always do is I put the initial side on the x-axis. So I put the initial side on the x-axis. And then from that point, I can rotate clockwise or counterclockwise. So if I rotate counterclockwise and get a terminal side, then this would be considered a positive angle. If I rotate counterclockwise, okay, then I would get a terminal side over here, and that would be considered a negative angle, okay? And if you look at this, let me draw another coordinate system and just show you this. When I start rotating, I can keep on going. I can rotate in either direction and end up with multiple rotations. And when that rotation stops, then I'd get a terminal side. Now, and notice how many times I rotate. So this is kind of a big deal. And so remember, initial side's always on the x-axis. Terminal side, whether you go clockwise or counterclockwise, depends on how large the rotation is. And then you can also rotate more than once. All right? Now, just briefly, we call these angles in standard position. Okay? If the initial side is on the x-axis, then, and the terminal side is a rotation around from there, then that's an angle in standard position. You can notice that if we set up a coordinate system and we have an initial side and then we rotate and get a terminal side, we could also rotate in the opposite direction and end up with the same terminal side, okay? And so you can have at least two, and the fact that we can rotate multiple times around, you can have a lot of angles match up with that terminal side. In fact, you could have an infinite number of angles that have the same terminal side. All right? But they're all in standard position if you start the rotation at the x-axis, no matter which direction you go. Okay? So one other thing we want to talk about, when you have angles in standard position, if you rotate like to here, this is going to be an angle in quadrant 1, right? If you rotate to here, you now have an angle in quadrant 2. And what we're referring to when we say that is we're referring to where the terminal side ends up. Of course, you can rotate to an angle in quadrant 3, and you could rotate to an angle in quadrant 4 as well. And quadrant 4. And of course, you can rotate to those angles going in the negative direction as well. So you can have negative angles in quadrant 1s, 2, 3, and 4. These are sometimes called quadrantal angles. Weird word. I've not ever really used it very much, but I do know how to find every angle in each quadrant. And so that's really important to be able to do. Okay? So this leads to the main theme of what we want to talk about vocabulary-wise, and that's the idea of what are coterminal angles. Well, if we think about just the word coterminal, whenever we put a co, that means that they have the same terminal angle or the same terminal side. So a coterminal angle is an angle with the same terminal side. Okay? And so we're going to play with some degrees here just a little bit in a moment. I'll kind of show you how these problems are done, how they appear. But basically, if I draw an angle, okay, and here's my angle, and I'm going to give it the name alpha, okay? Angle alpha. If I draw angle alpha in the standard position, then I want to draw a coterminal angle to angle alpha. Well, the easiest one to draw would be the negative, which would then also have the same terminal side, and that would be angle beta. And so angles alpha and beta are coterminal because they have the same terminal side. All right? And of course, you could then go in the positive direction, which is counterclockwise, more than one revolution, and end up at the same terminal side right there. And so that angle would also be coterminal. And we could even do the rotations more than once in the negative direction, and that angle would also be coterminal. And we could do this, we could rotate around this until we are crazy, and that angle would be coterminal. Okay? So coterminal angles are angles that have the same terminal side. Whoops. Sorry, I'm not quite sure where I lost the tape here. But we're going to do this with numbers, and we're going to do a couple of simple examples first. So I'm going to pick a classic. Here's my initial side on the x-axis, and I'm going to rotate to the perpendicular, and that's my terminal side. So what's the size of this angle? Do you know it? In your head, you should be saying, this is 90 degrees. Yeah, they're perpendicular because these are the coordinate axes. So this angle has a measure of 90 degrees. Okay? So I want to find a coterminal angle with that. In fact, I know that each quadrant is 90 degrees. So if I'm going to look for a coterminal angle, one coterminal angle I could get would be going in the negative direction. So that would be an angle whose measure is negative 270 degrees. Okay? So those angles are coterminal. It doesn't mean they're equal. It just means they have the same terminal side in the standard position. Okay? So what would be another angle that's coterminal to 90? Well, in that case, I play the game of doing more than one rotation. So what's one rotation? It's 360 degrees, and then I add 90 to that, So that is 450 degrees. So what happens here is we can start to see a little bit of a pattern. If I do the next one, right, and I do 2 rotations, well, 2 rotations is 360 twice. So what that means is if we let n equal the number of rotations in the positive direction, okay, then this angle will be 360 times n plus whatever the measure of the angle is. So let's call 90, we'll call it theta, the original angle. So it'll be 360 times n plus theta. All right. And so we add 90 to however many rotations of a full circle we're tacking on. And this will give us more positive coterminal angles. How many could we list? Well, we're only restricted by the value of n, how many rotations. And since we could have infinite number of rotations, we can have an infinite number of positive coterminal angles. Let's play this game going the other way. What if we go in the negative direction? If we're going in the negative direction, we start at 90, and essentially from the 90, we're going 360 degrees around the opposite direction. So what we do is we take negative 360 times the number of rotations in the negative direction, and then we add whatever our original angle is to it, theta. And that gives us all the possible negative coterminal angles. Now, are these formulas I want you to memorize? Not necessarily. You could put it in your notes and you can use it. But I want you to go beyond formula, and I want you to think about how I came up with this formula. Because the process I used to come up with the formula is essentially the process I used to figure this out. Okay? Now, in your practice, they give you a few problems, okay? And one of the things they say, what are the measures of a positive and negative angle coterminal to an angle of negative 148 degrees, okay? So I want 2 angles that are coterminal to negative 148 degrees. So all I have to do is I want to look at that on the picture. Now I know 90 in the negative direction, and then another 90 is negative 180. So negative 148 is right there somewhere. So here's my initial side. Here's my terminal side. There's the rotation of 148 degrees in the negative direction. Okay? I should use my lightsaber and make noises every time, right? Anyway, I'll try and remember to use it more often. So now, what's the next thing that we would do? The next thing we would do is we could just say, thinking about this, a positive angle that's going to be coterminal is this angle right here. Okay, and if you think about it, this is, I'm doing, I'm not quite doing a full rotation here, although you could think of it that way. So let me show you how you can think of it. This is kind of another way I've done this problem, but if you think I'm going all the way back around in the positive direction, okay? And that means I got to add 360 degrees. So I take 360 degrees and I add it to the angle that I had, 148. And that gives me, which, by the way, matches up with our formula. And then if I wanted a negative angle that was coterminal, I'm starting here and I'm going to go another 360 degrees in the negative direction. So I'm taking a negative 360 plus the negative 148. And if I do the math on these, this will be negative 508 degrees. And this one will be 212 degrees. All right. And those angles are coterminal to negative 148. So where this gets really interesting is, and I'm going to shrink this down a little more just so we still have it available. Where this gets really interesting is when we start to do this with radians, okay? And so if you'll remember, the radians, I could say I want to find angles that are coterminal to 2 pi over 3. Okay, so this angle is 2 pi over 3. So I want two angles coterminal to 2 pi over 3. So now this is in radians. So what's the difference? Well, a rotation in radians, if you'll remember, is 2 pi. One whole rotation is 2 pi. Just like with degrees, one whole rotation is 360 degrees. Now, why is it 2 pi? That is a very curious thing, okay? Why is it 2 pi? So I'm going to give you a simple explanation, and we're going to make it more complicated in a lesson or two. But here, and you'll see why it's always 2 pi, okay? In terms of the angles, not in terms of what the actual diameter and the length of the outside is, but in terms of the angles. If we just imagine we have a circle of radius 1, okay, then what's the circumference? Well, the circumference, if you'll remember, is the formula 2 pi r. Well, since the radius is 1, it's 2 pi times 1, or 2 pi. So all the way around the circle can be thought of as 2 pi. And then you might be going, hey, wait a second. The radius of a circle doesn't always have to be 1. It could be bigger or smaller than 1, and therefore the circumference will be different. However, in terms of measuring angles in radians, it will always be 2 pi. And this is a big secret about radians that often does not get taught if you've had trig before. And so I'm going to show you a very simple way to remember that. Okay, so let's find our two coterminal angles here. All right, let's snag our two coterminal angles to 2 pi over 3. Since 2 pi is like the 360, we could modify our formulas. We could say 2 pi times the number of rotations plus the angle theta, or negative 2 pi times the number of rotations plus the angle theta. So all I have to do is, if I go in the negative direction, I'm going to take negative 2 pi plus 2 pi over 3. And now I have to do that arithmetic. So negative 6 pi over 3 plus 2 pi over 3. And yes, you should not do this on a calculator. You should do this with fractions and get good at the denominator stuff. So negative 4 pi over 3 is one answer. And then the next answer, we're going to do a whole extra rotation to get around. So we're going to add 360 to the angle, or add 2 pi. So it'll be 2 pi plus 2 pi over 3, which will be 6 pi over 3 plus 2 pi over 3 equals 8 pi over 3. So there are our two coterminal angles. Okay? Any questions about finding coterminal angles? That's what you bring to class tomorrow. What I will say is that when I look at the practice, and the practice is like the quizzes, they say what angles are coterminal to like 170 degree angle. Very often you'll have multiple answers. Okay? So it's not going to be just one answer. So you need to check each of those answers. So if the angle was like 150 degrees and you were checking for coterminal, essentially what I would do is I'd add 360 to it. That's one more rotation around, and I'd subtract 360 on the degrees. And if it was given in radians, like 5 pi over 6, then I would add 2 pi and I would subtract 2 pi. And that's kind of the shortcut right there once you do this enough. But let me tell you, if you draw this out 150, okay, 150, this is a 150 degree angle, okay, 5 pi over 6. 5 pi over 6 is right here, okay. Actually, these are exactly the same. From yesterday, convert them, and notice you'll find out they're exactly the same. So there we go. So, and then you can think, add 2 pi, that'll get you right back. Subtract 2 pi, right? Add 360, subtract 360, okay? And that gets you right to where you want to go. And if you do that, then you're going to really kind of understand these problems. Okay? So, and then remember, if you're going to go 2 extra rotations, then it's not 360 anymore. It's 360 times 2, or 2 pi times 2. Okay, depending if you're doing degrees or radians. So that's all I have for you today. Good luck on the lesson and the quiz. You should be able to take the quiz at this point.